Under Iran, cities older than Sumer. Under the Gulf, a flooded world. On the island, melted rock. But last time was just the beginning. Iran holds an entire erased civilization and a language that's been waiting 5,000 years for someone to read it. A 5,000-year-old writing system, over 1,600 surviving tablets, geometric symbols, numerical notations, abstract signs that encode administrative records, trade transactions, and something else we cannot identify because no one has cracked the code. Proto-Elamite, the oldest undeciphered script on Earth. It predates Babylonian cuneiform by over 1,000 years. It was in use across the Iranian plateau from roughly 3,200 to 2,700 BC, across a territory spanning hundreds of kilometers, from Susa in the west to Tepe Yahya in the southeast. This was not a local experiment. This was a bureaucratic system deployed across a civilization large enough to need one. Consider the scale of that statement. A writing system doesn't appear in a vacuum. Behind every script sits an administrative apparatus, tax collectors, scribes, trade officials, a ruling structure sophisticated enough to require written records. Behind Proto-Elamite sits a civilization that was organizing its economy, recording its transactions, and governing its territory. At the same time, Sumer was doing the same thing across the border. And the civilization behind those tablets, Elam, operated parallel to Sumer, traded with it, fought wars against it, at times conquered it. A 3,000-year rival, filed under miscellaneous. While digging into this, we found something that should have set off alarms decades ago. Of the 1,600 known Proto-Elamite tablets, only a handful have been studied in any sustained academic program. Linear B, the Mycenaean Greek script, was cracked by Michael Ventris in 1952 with far fewer samples and far less institutional support. Egyptian hieroglyphics were deciphered in the 1820s using a single bilingual inscription on the Rosetta Stone. Proto-Elamite has 1,600 tablets. It has a numerical system that has been partially decoded. It has the entire toolkit of modern computational linguistics available to it. And it remains sealed. The most significant decipherment effort in recent history was led by Jacob Dahl at the University of Oxford's Wolfson College. His team digitized the tablets, built a database, opened the data to the public, and invited crowdsourced analysis. The result? Some numerical patterns were identified, some administrative structures emerged, but the script itself, the language it encodes, the grammar, the phonetic values, remains locked. And here is the part that deserves a red flag: funding. A Sumerian cuneiform tablet gets a department, a chair, a doctoral pipeline, grant cycles, conference panels. Proto-Elamite gets a digitization project and a hope that the internet might solve it. Same region, same antiquity, radically different attention. The question isn't whether Proto-Elamite can be deciphered, it's whether anyone with resources actually wants to. And the answer is hiding in the gap between what Elam was and what the accepted narrative turned it into. Elam. 3,000 years of continuous civilization, from roughly 2,700 BC to the Achaemenid conquest in the 6th century BC. Not a tribal confederation, not a vassal state, a kingdom with its own writing, its own religion, its own legal code, its own monumental architecture. At its peak, under Shutruk-Nahunte in the 12th century BC, Elam invaded Babylon and carried off the Code of Hammurabi, the most famous legal document of the ancient world, along with the victory stele of Naram-Sin and dozens of other Mesopotamian treasures, carried them back to Susa as trophies. That stele of Hammurabi, the one in the Louvre right now, the one every history textbook reproduces, wasn't found in Babylon. It was found in Susa, Elam's capital. The French archaeological mission under Jacques de Morgan dug it out of the Elamite Acropolis in 1901. The single most iconic artifact of Mesopotamian civilization was sitting in an Elamite palace. Think about what that means. Elam didn't just neighbor Mesopotamia, it rivaled it. At times, it dominated it. And yet, open any standard Western textbook on ancient civilizations, Mesopotamia, chapters. Egypt, chapters. Greece, chapters. Elam? A mention in a sidebar, a footnote, an afterthought between Sumer and Persia. Researchers at the University of Chicago's Oriental Institute, one of the few Western institutions to study Elam seriously, have pointed out that the overwhelming majority of Elamite texts remain untranslated, not because they're impossible, because there aren't enough scholars working on them, not enough funding, not enough institutional interest. The Elamite language has three known script phases: Proto-Elamite, Linear Elamite, and Elamite cuneiform, and all three remain partially or wholly undeciphered. 3 script phases, 3 millennia of civilization, and the academic world responds with a shrug. A kingdom that conquered Babylon gets less page space than a single Egyptian pharaoh. That's not an oversight, that's a choice. But here's what makes the Elam silence genuinely strange. Because erasing a kingdom from a textbook is one thing, erasing its technology is another. And the technology doesn't fit anywhere in what the curriculum teaches. The evidence is sitting in a desert 1,500 kilometers east of Susa, in one of the oldest cities ever excavated. Shahr-i Sokhta, southeastern Iran, Sistan-Baluchistan province. A flat, wind-scoured desert plain stretching to the horizon, the air so dry it cracks your lips before you finish a sentence. The site covers over 150 hectares, a Bronze Age city that thrived from roughly 3200 to 1800 BC. Researchers from the University of Rome, the Iranian Cultural Heritage Organization, and independent teams have excavated the site across multiple decades, and what they pulled from the ground rewrites the timeline of human capability. Start with the eye. In 2006, archaeologists recovered an artificial eyeball from a female burial, 2800 BC. The prosthetic is hemispherical, roughly 2.5 centimeters in diameter, made of a lightweight paste with a tar-based coating, etched with a fine pattern of capillary-like gold wire lines radiating from a central circle to mimic the iris and the blood vessels of a real eye. Upon closer inspection, the craftsmanship is staggering. Whoever made this understood optics, anatomy, and cosmetic realism at a level that shouldn't have existed in the 3rd millennium BC. Microscopic analysis of the eye socket showed clear signs of long-term wear, abrasion marks on the bone that matched decades of contact with a prosthetic surface. The woman wore this device during her lifetime, not a burial ornament, a medical device. Carbon dating puts this at nearly 5,000 years old. The next known prosthetic eye in the historical record appears roughly 2,000 years later in Roman-era medicine. Then, the game. Excavators found a board game with carved stone pieces and dice dated to the same period. Based on the analysis of the playing surface and the distribution of pieces, it's the oldest known board game in the world, predating the royal game of by centuries. A civilization with enough surplus time and cognitive sophistication to invent structured games, abstract thinking, strategy, competition, at a date when the accepted narrative barely credits the region with organized settlement. Then, the skulls. Multiple skulls from the burial site show evidence of cranial surgery, trepanation, clean circular holes cut with a precision instrument with bone regrowth around the edges. The regrowth is the key detail. It confirms the patients survived the procedure. Not just survived the moment of surgery, but lived long enough afterward for the skull to begin healing. Someone in this city, 4,800 years ago, was opening the human skull with a controlled technique, performing whatever procedure they intended inside, and closing up with a success rate high enough that they kept doing it. This discovery is documented in peer-reviewed Iranian and Italian archaeological journals, published, catalogued, confirmed. Prosthetic eye. Board game. Brain surgery. All from a single Bronze Age city in a corner of Iran that most Western scholars have never visited. And yet, the reaction from the broader academic community has been a polite nod, followed by silence. No major Western documentary series has devoted an episode to Shahr-i Sokhta. No blockbuster book. No viral lecture circuit. A city with 5 simultaneous firsts in human history, and it sits quietly in the specialist literature, unvisited, underfunded, under-discussed. A city that was performing neurosurgery before the pyramids were built. Try fitting that into what the curriculum teaches. But the most disturbing part is what comes next, because Shahr-i Sokhta isn't the end of the story, it's the midpoint. The strangest evidence of Iranian engineering isn't in a museum or a burial site, it's standing, or it was standing, in the middle of the Kerman Desert, and it was built from dirt. Arg-e Bam, the largest mud brick structure on the planet. A fortified citadel covering roughly 180,000 square meters, towers, ramparts, residential quarters, a bazaar, a mosque, a governor's complex, all built from sun-dried earth bricks, straw, and clay mortar. The earliest layers of construction date to approximately 500 BC during the Achaemenid period. The fortress was continuously inhabited, repaired, and expanded for 2,500 years. 25 centuries of earthquakes, sandstorms, invasions, and baking desert heat, and it stood. Until December 26, 2003, when a 6.6 magnitude earthquake struck directly beneath the city of Bam, killing over 26,000 people and destroying roughly 80% of the citadel in a matter of seconds. What 2,500 years of nature couldn't do, a shallow focus seismic event did in under a minute. And now, the numbers. 2,500 years. That is how long a structure made of mud stood in an active seismic zone, in a desert climate with temperature swings from below freezing to over 45 degrees Celsius, with monsoon-level rainstorms during the wet season and zero humidity for months at a time. Modern reinforced concrete, the material we consider the backbone of contemporary construction, has an expected structural lifespan of 50 to 100 years. Exposed concrete in marine or industrial environments degrades in as little as 30. High-rise buildings constructed in the 1960s are already being demolished because the rebar is corroding inside the concrete matrix. The Pantheon in Rome, built with Roman pozzolanic concrete 2,000 years ago, is an engineering marvel precisely because it has lasted so long. Arg-e Bam, built from mud, lasted 5 centuries longer than the Pantheon. When measured with modern instruments, the wall cross-sections of Arg-e Bam reveal a layered construction technique, alternating courses of different clay compositions with straw fiber reinforcement and external plaster layers designed to shed water and resist wind erosion. The walls taper slightly, thicker at the base, narrower at the top, distributing lateral loads in a way that mirrors modern structural engineering principles. The thermal mass of the mud walls naturally regulated interior temperatures, cool in summer, warm in winter, a property that contemporary architects now call passive climate design and bill as an innovation. Not bad for dirt, but the engineering riddle isn't just that mud lasted longer than concrete. It's the question the engineering raises, because a civilization that could build Arg-e Bam didn't stop there. 60 kilometers south of Susa, they built something that shouldn't exist at all. Chogha Zanbil, a ziggurat in Iran. That sentence alone is a contradiction, if you follow the departmental line. Ziggurats are Mesopotamian. They belong to Sumer, Akkad, Babylon, Assyria, the civilizations between the Tigris and the Euphrates. Every standard reference book places ziggurats within the Mesopotamian cultural sphere. Chogha Zanbil breaks that rule. Built around 1250 BC by the Elamite king Untach-Napirisha, this stepped temple pyramid is the best preserved ziggurat in existence, better preserved than any in Iraq. It was dedicated to the Elamite god Inshushinak. UNESCO designated it a World Heritage Site in 1979, the first in Iran. And the French archaeological mission, led by Roman Gierschmann, which excavated the site between 1951 and 1962, uncovered something far more complex than a simple religious monument. Here's what no one says out loud. The structure originally rose 5 tiers to a height of approximately 53 meters, taller than a 15-story building. Even in its current state, 3 surviving tiers, it reaches over 25 meters. The construction method is concentric. Each tier was built as an independent structural box, one nested inside the other, each standing on its own foundation. Not stacked, nested. If one tier collapsed, the inner tiers would remain standing, a redundancy principle that modern structural engineers call progressive collapse resistance. The bricks are inscribed, thousands of them, with cuneiform dedications in Elamite pressed into the clay before firing. The mortar is bitumen-based, natural petroleum tar quarried from surface deposits in Khuzestan, giving the joints a waterproof seal that has held for over 3,200 years. The site complex extends far beyond the ziggurat itself. Gershman's excavations revealed a planned temple city, an inner sacred precinct surrounded by a middle wall, surrounded by an outer wall, all enclosed within a massive rectangular temenos. Inside the walls, subsidiary temples to multiple Elamite deities, a royal palace, water channels, and a series of vaulted underground chambers whose function remains debated. The total enclosed area covers over 100 hectares. This wasn't a lone tower in the desert. This was a planned, sacred capital. Cross-referencing these findings with Mesopotamian ziggurats reveals something uncomfortable. The Mesopotamian ziggurats in Ur, Uruk, Eridu are mostly ruins, foundation remnants, reconstructed guesses. The famous ziggurat of Ur was rebuilt by Saddam Hussein's government in the 1980s. What tourists photograph is modern brickwork over ancient foundations. Chogha Zanbil is standing. Original bricks, original mortar, original inscriptions. The best example of a ziggurat on Earth is not in Mesopotamia. It's in Iran, in Elam, in the civilization that gets a footnote. And that's barely scratching the surface. Because Chogha Zanbil proves something that the departmental line has no mechanism to address. Elamite monumental architecture wasn't derivative. It wasn't borrowed. It wasn't an imitation of Mesopotamian models. The concentric, independent tier design at Chogha Zanbil has no parallel in any known Mesopotamian ziggurat. Mesopotamian ziggurats were built as solid core platforms, tier stacked on tier, with the weight of the upper structure pressing down on the lower. If the core failed, the whole thing came down. The Elamite design distributes weight differently. Each tier is structurally autonomous. The Elamites weren't copying. They were engineering independently, and the results outlasted the originals by millennia. So, what happens when a civilization that rivals Sumer conquers Babylon, performs brain surgery, builds structures from mud that last millennia, constructs the world's best-preserved ziggurat with engineering superior to the Mesopotamian originals, and writes in a language no one can read? What happens when that civilization is simply left out of the story? 1 second. Because the answer to that question is not archaeological, it's political, and it changes everything about how we read the map of ancient history. Iran sits at the crossroads of every major ancient trade route: the Silk Road, the Persian Royal Road, the maritime routes through the Persian Gulf and the Indian Ocean. The geological record shows continuous human habitation on the Iranian plateau stretching back over 100,000 years. The territory contains some of the earliest known evidence of agriculture, animal domestication, and metallurgy. In terms of sheer density of ancient civilizations per square kilometer, Iran has no rival. Elam, the Giroft culture, the Medes, the Achaemenids, the Parthians, the Sassanids, layer upon layer upon layer. Civilizations stacked on top of each other across 12,000 years of recorded history. And the silence is structural, not accidental, not temporary, structural. Here's what that looks like in practice. Western academic institutions allocate funding and faculty positions based on institutional tradition, political relationships, and strategic relevance. The evidence points to a clear pattern. Countries with stable Western diplomatic relationships, Egypt, Greece, Italy, Turkey, receive disproportionate archaeological investment. Countries under sanctions, political isolation, or academic boycotts, Iran, Iraq during certain periods, Syria, Libya, see their archaeological heritage deprioritized, defunded, or simply ignored. The stratigraphic data is unambiguous. The evidence exists. The sites are there. The artifacts are real. The tablets are waiting. The question is, who gets to decide which civilization matters enough to study? Jacob Dahl at Oxford has said publicly that Proto-Elamite could be cracked with adequate funding and sustained institutional commitment. The tablets are digitized, the data is available, the computational methods exist. What's missing is the will. What's missing is a decision somewhere in a funding committee, in a department meeting, in a university boardroom that says this civilization is worth understanding. Compare that to the resources poured into Egyptian archaeology. Hundreds of millions of dollars in international funding since the 19th century, entire university departments dedicated to Egyptology in dozens of countries, a permanent stream of doctoral candidates and postdoctoral fellowships. Now count the number of dedicated Elamite studies programs in the Western world. You can do it on one hand. Until that imbalance is corrected, Elam remains a blank page. Proto-Elamite remains locked. Shahr-i Sokhta remains a curiosity, a city with prosthetic medicine, neurosurgery, and abstract games, sitting in the specialist literature unvisited. Arg-e Bam remains a ruin that most architecture students have never heard of, a structure that proved mud can outlast steel-reinforced concrete, ignored in every structural engineering textbook. And Chogha Zanbil, the best-preserved ziggurat on Earth, with an engineering solution more advanced than its Mesopotamian counterparts, remains a footnote in a chapter about someone else's civilization. Here's the question this video can't answer, because the answer isn't in the ground. It's in the institutions. A language waits 5,000 years. The tablets are digitized. The tools exist. The methods are ready. But nobody with the budget is making the call. Is that negligence, or is it a choice? And if it's a choice, who benefits from a civilization that rivaled Sumer, conquered Babylon, and engineered structures that outlast anything we build today, staying unread? Iran. Stacked civilizations, undeciphered scripts, engineering from mud that lasted 2,500 years, all absent from the curriculum. But where did this knowledge come from? The Sumerians had an answer: beings who descended and gave humanity everything. Next, the Anunnaki. And the question, what if the myth is a logbook,